Hello and welcome to Empowered Learning. This video will be about finding the zeros of a linear function. And so in general, whenever we find a zero of some function, whether it is linear or not, it is just the value or values of x that we can plug into the function that give us a result of zero. Or if we are looking for a point on the graph where its y-coordinate is 0, what are the corresponding values of x that make that happen if we're looking at it from a graph perspective? And so one of the things that we want to make sure that we understand whenever we're talking about the zeros of a function is that they're very similar and are related to what an x-intercept is as well as what a root is. And so an x-intercept, of course, is a point on the graph where the line or function in general crosses the x-axis. So let's say if we had a line that looked like this, then this would be the place of the x-intercept. And so let's say if that point was the point 2, 0, that would be the actual x-intercept, and x equals 2 would be the 0 for that particular function. A root is just a more fancy way of saying for some function its value equals 0, but what root implies is whether we're talking about real numbers or complex numbers. And so for instance, if we had, let's give you an example here. So let's say we wanted to look at something like this, right? And we needed to figure out, well, what value of x here is going to make this function 0? If we look at a graph of this function, it would look like this. And of course, we know that it would be impossible to do it. But one of the things that we do know is that for here, one of the numbers that would allow this to be 0 would be a negative square root of 5i. Okay. And another one would be a positive square root of 5i. And if I plug that in, let's say the positive one, let's say if I'm just going to call this b here. So if I plug that in and did that, then of course, when we use our exponential rules, we would know that we would have square root of 5 squared times I squared plus 5. And so I'm going to move this down here. Guess let's move it back. Don't know why it's doing that. We'll take this and move this here. And then, okay, all right. So we're looking at this and we do that, then of course square root of 5 squared is just 5, and I squared from knowing about complex numbers is -1. And then of course from there we get a -5 plus 5 is equal to 0. Now if you're unfamiliar with complex numbers, you don't necessarily need to know that for this particular video. I'm just giving you an example of what root is implying. When we say that it is similar to a 0, it is just saying that it can be a real or complex number in doing that. All right, so again, all that I've been saying here in general, an x-intercept, 0, or root of a function all describe the same thing. The graph of the point whose y-coordinate is 0, and of course we have a slight difference. X-intercept is basically an ordered pair. The 0 of a function gives answers as a value, as location on the graph. And so for a root, that can apply, same thing as a 0, but it can apply to both real and complex numbers. Whereas for x-intercepts and zeros, in general, there must always be real numbers. You'll see in some text where they will actually say the zeros of a function, and they will use complex numbers with that as well. But technically, if you refer to it that way, it should be a root. All right, so anyway, let's go ahead and get to the examples here. And so we want to find the zeros of a given function, okay? So in other words, we want to know what is x when y is 0, okay? That's basically what we're trying to do here. In this case, for this first one here, all we have to do is just plug in 0 for y. And if we do that, we know that this term here goes to 0, which means we just have this, and we can divide by 8. And here we see 2 8s reduces to 1/4. So x equals 1/4 would be what our 0 is, meaning the value of x that we can plug into this equation to get a y value of 0. Okay. Same deal here. If we plugged in 0 right here, then we would just have 4x is equal to 5, and then we just divide by 4, and that will be 5/4. For our next example here, x is equal to 5. We know that that is a vertical line. And of course, drawing this to kind of give us some perspective here, that is this vertical line. And we know that since this has a point on its graph of 5, 0, then x equals 5 would be the actual 0. Okay. Now for y equals -8, we know that looks like a line that is horizontal, that's below the x-axis. And if you notice, this line does not have any points that are on the x-axis here. Okay, in other words, points with a y-coordinate of 0. So for this one, it would be none, or no solution. And of course, for our example E here, we see that, again, we would just let y equal 0. If we do that, then we end up with 4x is equal to 12, divide by 4, and we get x equals 3. So the 0 of this function would be x equals 3. So this concludes our video for the zeros of a linear function.